Today we're going to look at exact first order differential equations, and we're going to use it using this as an example here. Now if I saw this in an exam, what I would do is I'd first of all try and solve it using simpler methods. For example, can we do it by separation of variables, where we can get it in the form of dy over f of y equals dx over g of x? Well, clearly we can't, so we can't use separation of variables. What about homogeneous? Well, we can see the degree of this is 3, the degree of that is only 2, and the degree of that is 3, and the degree of that is 0. So the degree isn't the same, so we can't use homogeneous solutions. We can't see any obvious substitution, and certainly we can't get it into the form dy dx add f of x y equals g of x, where we could use an integrating factor. We can't use any of those. Once you've gone through all those and realised none of them work, the next thing is always look at exact differential equations. Okay, so what we're going to do is a 5-step of how to do it. Okay, step 1, we have to put it in the form mxy dx add n xy dy equals 0. Okay, well that's quite easy. That'll be my apologies, x y squared add 3. Well, this is our equation, isn't it? It is 5y squared minus x squared y dy dx. Okay, what we've got to do is we've got to move that over the other side. Make sure that this is a plus. That gives us x y squared add 3 dx add, flip these two around because of the sign, x squared y minus 5y squared dy equals 0. So now we got it in the correct form, and this bit here is the m, and this bit here is the n. Okay, now the second thing, and this is what makes it a exact differential equation, is that the partial derivative of m with respect to y is the same as the partial derivative of n with respect to x. And we have to check this, because if this isn't the case, then it's not an exact differential equation. So let's have a look here. There's m and there's n. So let's partially differentiate m with respect to y, and that will give us 2xy. And if we partially differentiate n, remember that's n, with respect to x, that gives us 2xy. Oh good, hey presto, they're the same. Therefore this is exact differential equation, so we can move on to step 3. Step 3, we need to integrate both m dx and n dy. Okay, so we need to integrate first of all xy squared add 3 dx. Okay, so let's do that. So that will be equal to x squared over 2y squared add 3x add some g of y. Okay, we're going to come back to that in a minute. And the integral of n, which was x squared y minus 5y squared dy, the integral of that is x squared y squared over 2. Note that and that are the same, which will always be the case, minus 5y cubed over 3 add h of x, which is there. Now, what is going to happen is that the 3x is the h of x, and the minus 5y cubed over 3 is the g of y, because what we're going to do in step 4 is we merge these two results, and that gives us our answer. So we merge the two results here to give the general solution, which means, therefore, that our general solution, psi of xy, is the f plus g plus h, will be equal to x squared y squared over 2. Remember, don't double count this, we're just merging the results, minus 5y cubed over 3 add 3x, and therefore the general solution is x squared y squared over 2 minus 5y cubed over 3 add 3x equals c, where c is the constant of integration. Okay, now in step 5, what we do is we use the initial condition, and the initial condition was y of 1 equals 0. We use that on this to get our value of c. We're putting in x equals 1 and y equals 0 into that. We get 3 times 1 equals c, i.e. c equals 3. And so therefore our solution is x squared y squared over 2 minus 5y cubed over 3 add 3x equals 3. And that is the solution to the first order differential equation per the question. Now, for those of us who are feeling a little bit masochistic and quite fancy checking this, What we can do is step 6, which is definitely a bonus step. You don't have to do it in an exam, but what we could do is we could use implicit differentiation to just check that we actually do get back where we start. So let's just have a look. X squared y squared over 2. This is our solution, minus 5y cubed over 3. Add 3x equals 3. Well, why not differentiate this with respect to x? Okay, so what do we get? Well, we're going to get, so we're using the product rule, we're going to get 2x y squared over 2, add x squared over 2 times 2y dy dx, minus 15y squared over 3 dy dx, add 3 equals 0, and that's just differentiating using implicit differentiation. And now all we need to do is collect everything up. That's xy squared, add 3 equals, and take the dy dx over the other side, 5y cubed, 5y squared, sorry, minus x squared y dy dx, which was our question in the first place. So by differentiating our solution, we do get back to our first order differential equation, and therefore it is correct. Well, if you found this useful, please like this video by pressing the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.